Okay, going to try to talk fast so you can't watch this on double speed. We're going to do a lot with angles like we did with segments. So we've got the ruler postulate for segments and we've got the protractor postulate for angles. Just postulate says you can measure any angle by putting a protractor on it. But more importantly, when we get the protractor postulate, that gets us into the angle addition postulate. Just like the segment addition postulate, this says if you have two angles right next to each other, you can say the big one is the sum of the smaller two. What's really important is this idea that instead of a point being between two endpoints of a segment, we now have a point on the interior of an angle. Now, in a geometry class, we are going to say that for any angle, the interior is the side less than 180 and the exterior is the side outside. We're not going to worry about these angles here being more than 360. We only want to know in between 0 and 180. So I skipped over a slide and we'll go back to it. One I'm sure you know, one that you need to know, and that's that angles can be classified as acute, right, obtuse, or straight. So straight angles just means straight line. Good? Straight angles mean straight line. Right angles you know, acute angles you know, obtuse angles you know. We've talked about all this. Notice some language. We're talking about the measure of an angle. Look at the notation that you've seen before, referring to an angle by a capital letter. Good? Another thing that we can refer to an angle by is three letters that make up the angle. So just to get some terms that you're going to put down in your binder or in your dictionary, which I have by the way, is we can name an angle by its point here. So let's call this angle A. You can also name it with a few points on what are called the sides of the angle. So if this was B and this was C, you could call it angle BAC. BAC, or you can call it angle CAB. It's all the same. A is called the vertex. AC is a ray, and that's a side. AB is a ray, and that's a side. Sometimes they put little numbers in here, so you can even call it angle 1. Good? Or they might put a little lowercase letter in here, A, and they might say, what is A in degrees, right? All sorts of things like that, but I like, little one there. Back to the angle addition postulate. We are going to use the angle addition postulate much like we use the segment addition postulate. So you're going to see problems in your homework tonight that look something like this, or in your classwork tomorrow. They might say that this is 3x plus 10, and then that this is, 4x minus 5, and then they might say the whole angle is 10x minus 20. Good? And then by the angle addition postulate, we know that 4x plus negative 5 plus 3x plus 10 equals 10x minus 20. That means that 7x plus 5 equals 10x minus 20, and then you would get 25 equals 3x. So x equals 25 divided by 3. Now be careful in a geometry class because they might say, what's the measure of angle BAD? And you did all this work to get x, which is correct, but then you didn't substitute this back in and solve. So you put 25/3 in here, you get 250 over 3, you subtract 20, which is 60 over 3, and you get 190 over 3, which is about, someone's probably beating me to it, 63.3 repeating, right? So this whole angle is 63.3 repeating degrees. Or they might ask you for what angle CAD is, or they might ask you what angle BAC is. But the point is x is not always the answer, it's part of the answer. Notice you cannot call this angle angle A. because I don't know which one you mean. Do you mean this one? Do you mean this one? Do you mean the whole thing? So in a picture like this, the only way you can refer to angles are angle BAC, CAD, or BAD, or any of those three in reverse. DAB, DAC, CAB, DAB, angle dab. You can't tell right now, but I'm dabbing. Just like we did with segments, we can also talk about what it means when we have two angles that are the same size. We call those angles congruent. So congruent angles mean they have the same measure. You need to be careful because measures are equal, angles are congruent. I know that seems weird right now, but we say shapes are congruent, we say numbers are equal. This is just like with segments, right? Measures equal of segments, segments congruent. We do the same thing with angles. Another thing that's really important is we can have what's called an angle bisector. Now, I put the definition of segment bisector back up on this slide because I want you to read it closely. They are different definitions. A segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. What that means is if we know something is a segment bisector, then we know the intersection of that thing and the segment are a midpoint. In this case, we know M is the midpoint because CD, the line, is a segment bisector of AB. For an angle bisector, we're told it's a ray that divides the angle in two. We're gonna do something in geometry called proofs. And in a proof, if we know something's a segment bisector, then we have to say we know the midpoint, then we can say the segments are cut in half. For angle bisector, we're just allowed to go straight to the half. Good? I know it's weird, but the way these definitions work are precise. Segment bisector implies midpoint. Midpoint implies that the segments are cut in half or equal. Angle bisector means the angle is cut in half. So you'll get some good problems like this where you're told, ray AD is an angle bisector of angle CAX. So you draw this picture, you say here's C, here's A, here's X. It's an angle bisector, ray AD, so it has to be in the middle, and it cuts it in half. One way to show that is to put an arc here and an arc here. Because there's one arc, I know it's congruent to any angle with another arc. You can use two arcs or three arcs. Sometimes they'll take an angle and they'll put like a little dash on it too. And any other angle that has an arc with a dash is congruent. I'll use both. So I might say that this is 4x plus 18 and that this is 7x minus 5. And you now know these are equal. So you could solve 7x minus 5 equals 4x plus 18. You get 3x equals 23. And so x is equal to 23 over 3. Again, be careful. They might be asking you to find one of these angles, in which case you need to substitute x back in and get a measure.